E-Chemistry class, Fatima Convent High School, myself, Dipali. Chapter 3, Metals and Non-Metals. In this second session of this chapter, we are going to study about the chemical properties of metals and non-metals. Chemical properties of metals and non-metals. We have learned about the chemical properties of metals in the following section 3.2.1 to 3.2.4. For this, collect the samples of following metals: aluminum, copper, iron, lead, magnesium, zinc, and sodium. Now let us see the first property, that is what happens to metal when it is burnt in air. Now you must have seen in activity 3.8 that magnesium burns with a dazzling flame of white color when it is burnt in air. Do all metal reacts in same way? Let us check by the following activity. Let us do activity 3.9. The following activity needs teacher's assistance because you need to protect your eyes. Now take a sample of the above mentioned metals. Hold any of the sample taken above with a pair of tongs and try burning over a flame. Repeat with the other metal samples. Collect the product if formed. Let the product and metal surface cool down. Which metal burns easily? Now, when you will see that magnesium burns easily in air than the other metals, what color does sodium, magnesium, copper, and aluminum impart to the oxidizing flame? So, we see that sodium Na gives yellow color. Then magnesium Mg gives dazzling white flame. Then Cu gives greenish blue flame, and aluminum gives white flame. So these are the colors of the flame which we obtain on burning. Now how does the metal surface appear after burning? They will be silvery white. Now arrange the metal in the decreasing order of their reactivity towards oxygen, means which reacts first. And what is the solubility of these products which are obtained after burning? So the reactivity can be written as Na, Mg, Al, Zn, Fe, Pb, and Cu. So sodium burns the fastest and copper the slowest. And in solubility, the product obtained by the reaction of Cu, Fe, Zn, and Al are insoluble in water. And amongst the given metal, only sodium metal on heating forms oxides which is soluble in water. So we can based on this, we can say that the metal oxides are as basic in nature after the following test. Almost all metals combine with oxygen to form metal oxide. This is the general equation. For example, when copper is heated in air, it combines with oxygen to form copper oxide, a black oxide. The color of copper oxide is black. Similarly, aluminum forms aluminum oxide. Recall chapter 2 how copper oxide reacts with hydrochloric acid. We have learned that metal oxides are basic in nature. But some metal oxides such as aluminum oxide, zinc oxide show both acidic as well as basic behavior. And such metal oxides which show both acidic as well as basic characters to produce salt in water are known as amphoteric oxides. Aluminum oxide reacts in the following manner with acids and bases. Al2O3 plus 6HCl gives 2AlCl3 plus 3H2O. Al2O3 plus 2NaOH gives 2NaAlO2 plus H2O. Most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolve in water to produce alkalis. So, here is the basic chemical property of a metal reacting with air. Now, we have observed in activity 3.9 that all metals do not react with oxygen at the same rate. Different metals show different reactivity towards oxygen. That is its chemical property. Metals such as potassium and sodium react vigorously and they catch fire if kept in open as well. Hence, to protect them or to prevent accidental fires, they are immersed in kerosene oil. This can be asked as a give reason that why potassium and sodium are kept in kerosene. Now you know the reason, that because they catch fire when kept open in air, they are supposed to be kept in a kerosene oil. At ordinary temperature, the surface of metals such as magnesium, aluminum, zinc, lead, etc. are covered with thin layers of oxide. The protective oxide layer prevents the metal from further oxidation. Iron does not burn on heating, but iron filings burn vigorously with sparkles in the flame of the burner. Copper do not burn, means that is least reactive. But the hot metal is coated with a black colored layer of copper oxide. Silver and gold do not react with oxygen even at high temperature. So, we can say that the reactivity of metal with oxygen varies from metal to metal, and we can see what type of oxides they form, some basic and some acidic, and they give amphoteric oxides. Now, what is anodizing? Anodizing is a process of forming thick oxide layer of aluminium. Like corrosion, this is anodizing, where aluminum is coated with aluminum oxide. Aluminum develops a thin oxide layer when exposed to air. This aluminum oxide coat makes it resistant to further corrosion. The resistance can be improved further by making the oxide layer thicker. During anodizing, a clean aluminum article is made the anode and is electrolyzed with dilute sulfuric acid. The oxygen gas evolved at anode reacts with aluminum to make a thicker protective oxide layer. This oxide layer can be dyed easily to give aluminum articles an attractive finish. Now, do you understand how aluminum is anodized? After performing activity 3.9, you should observe that sodium is the most reactive of all the samples of metal taken, and the reactivity of magnesium is less vigorous, implying to it is not as reactive as sodium. But burning in oxygen does not help us to decide about the reactivity of zinc, iron, copper or lead. So let us perform some more reactions to arrive at the conclusion about their reactivity. Now let us look into the second property. What happens when metal reacts with water? Then when metal reacts with water, put a small piece of sample separately in the beaker half filled with cold water. Which metal reacts with cold water, and arrange them in the increasing order of their activity with cold water. So if you try to observe, sodium and potassium and calcium react with cold water. Sodium, Na, potassium and calcium react with cold water. Then which metal did any metal produce fire on water? Yes, sodium and potassium will catch fire when in water. Does any metal start floating after some time? Yes, calcium and magnesium will start floating after some time. Which put the metal that did not react with cold water in a beaker half filled with hot water. You will see that magnesium did not react with cold water but it reacted with hot water. From the metals that did not react with hot water, arrange the apparatus and observe this reaction with steam now. You will see that aluminum, iron and zinc do not react with cold water or hot water but they react with steam. Which metal do not react with even steam? Then metals like Pb, that is lead, copper, silver and gold do not react with steam. Now if we arrange the metals in their reactivity order, we get K, that is potassium, sodium, calcium, magnesium, aluminum, zinc and iron. Pb, Cu, Ag and Au, that is lead, copper, aluminum, silver and gold do not react with water. Whereas metals like sodium, potassium and calcium, when you put them in the reactivity order with water, then Ca, Na and K. So, did you understand? The metal oxides are soluble in water and form metal hydroxides. Metal reacts with water and produces metal oxide and hydrogen gas. And these metal oxides are soluble in water and form metal hydroxides. Metals like potassium and sodium react violently with cold water and evolve hydrogen gas which catches fire immediately. Here is a setup to show the action of steam on metals. Now metals react with water and produce oxides and hydrogen gas. Metal oxides are soluble in water and it is further forms metal hydroxide. But all metals do not react with water. We already saw which metal reacts with water and which do not. So metal plus water gives metal oxide plus hydrogen and metal oxide plus water gives metal hydroxide. Metals like sodium and potassium react violently with cold water. In case of sodium and potassium, its reaction is so violent and exothermic that it evolves hydrogen gas immediately catches fire. So the reaction is 2K plus 2H2O gives 2KOH plus H2 plus heat. 2Na plus 2H2O gives 2NaOH plus H2 plus heat. The reaction of calcium with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. Ca plus 2H2O gives CaOH twice plus H2. Calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Magnesium do not react with cold water, it reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Metals like aluminum, iron and zinc do not react with cold water or hot water, but they react with steam to form metal oxide and hydrogen. So it is very clear from this the reactivity of metal with water also is different. Now 2Al plus 3H2O gives Al2O3 plus 3H2 and 3Fe plus 4H2O gives Fe3O4 plus 4H2. These are the reactions which you have to learn. Metals such as lead, copper, silver and gold do not react with water at all. So there are lots of exceptions for the metals reacting with water as well. Now let us see the third property. What happens when metal reacts with acid? We have already learned that metal reacts with acid to give salts and hydrogen gas in the previous chapter. So metal plus dilute acid gives salt plus hydrogen. But do all metals react in the same manner? Let us check with an activity. Now put the sample separately in the test tube containing dilute sulfuric acid. Suspend thermometer in the test tube so that their bubbles are dipped in the acid. Observe the reaction of formation of bubbles carefully. Which metal reacts vigorously with dilute hydrochloric acid? You will see that magnesium reacts vigorously with hydrochloric acid. Which metal do not react with hydrochloric acid? Then copper do not react with hydrochloric acid. Which metal rises the temperature to the maximum? Then again magnesium rises the temperature to the maximum. Copper does not react at all. And arrange this in the decreasing order of the reactivity, we get Mg, Al, Zn, Fe. So it's very clear from this what are the reactivity of the metal with an acid. Write for the equations for the reaction of magnesium, aluminum, zinc and iron with dilute hydrochloric acid. Hydrogen gas is not evolved during this reaction. This is going to be your homework. Hydrogen gas is not evolved when metal reacts with nitric acid. It is because HNO3 is a strong oxidizing agent. It oxidizes the H2 produced to water and itself gets reduced to any of the nitrogen oxides. N2O, NO, NO2, but magnesium, Mg and manganese react with very dilute HNO3 to evolve H2 gas. You must have observed in the activity 3.11 that the rate of formation of bubbles was the fastest in case of magnesium. The reaction was also the most exothermic in this case. The reactivity decreases in the order of Mg, Al, Z and Fe. In the case of copper, no bubbles were seen and the temperature also remained unchanged. This shows that copper does not react with dilute HCl. So we can say so many metals reacting with acid, but they have exceptions again. Now, what is aqua regia? Aqua regia is the royal water. It is freshly prepared mixture of concentrated hydrochloric acid and nitric acid in the ratio of 3:1. It can dissolve gold even though neither of these acids can do alone. Aqua regia is highly corrosive fuming liquid. It is one of the few reagents that is able to dissolve gold and platinum. Now let us see the next property. How do metal reacts with solutions of other metal? Take a clean wire of copper and an iron nail. Put the copper wire in a solution of iron sulfate and iron nail in the solution of copper sulfate taken in the test tube. Record your observation after 20 minutes. In which test tube did you find the reaction to occur? Obviously, we find the reaction to occur On what basis can you say that a reaction has actually taken place? Can you correlate your observation for activity 3.9, 3.10 and 3.11? Write balanced equation for the reactions that has taken place and name the type of reaction. So let us answer this question. The following reaction occurs in test tube containing iron nail dipped in copper sulfate solution. That is, the reaction would be Fe plus CuSO4 will give FeSO4 plus Cu. In this reaction, more reactive Fe has displaced less reactive copper. Now, on the basis of what we can decide the actual reaction, the blue color of copper sulfate has turned green during the reaction. This change indicates that the reaction has occurred. So, blue color of copper sulfate has turned to green color. So, the reaction has occurred. It is a displacement reaction where copper was displaced by iron. Because iron is more reactive than copper, the reaction does not take place in the other test tube. And the reaction in which more reactive metal displaces a less reactive metal from its salt solution or can displace from its molten state is called displacement reaction. Among iron and copper, iron is more reactive than copper because reactivity of iron is more. This is what the experiment teaches us, that reactive metals are displaced less reactive metals from their compounds in the solution or in the molten state. We have seen in the previous section that all metals are not equally reactive. We check the reactivity of various metals with oxygen, water and acid, but all metals do not react with their reagents. So we were not able to put all the metal samples we had collected in decreasing order of the reactivity. But displacement reaction studied in chapter 1 gives better evidences that the reactivity of metal, the simple and easy, if metal A replaces metal B from its solution, then B is more reactive. So metal A plus salt solution of B, salt solution of A plus B. Which metal, copper or iron, is more reactive? Obviously, iron is more reactive in our observation. So let us have a look at the reactivity series. The reactivity series is nothing but the list of metals according to their increasing order of reactivity or decreasing order of reactivity. So series is a list of metals arranged in the order of their decreasing activities. After performing displacement experiment, we come to the final result of the reactivity series, where potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, which is a non-metal, copper, mercury, silver and gold are arranged in the decreasing order of their reactivity. The most reactive from this is potassium and the least reactive from this is gold. Now you will be easily able to answer this in-text questions. Let us check the next section. How do metals and non-metals react in the next session? Thank you.